Okay, so today what we're looking at is we're looking at quadrilaterals. And remember, quadrilaterals are four-sided polygons. And the thing about quadrilaterals is that we have some quadrilaterals that have some special properties. Okay, it's really important to remember which quadrilaterals they are. But first I'm just going to talk about convex and non-convex quadrilaterals. So once again, if two sides meet, that's called a vertex. And there are obviously four vertices in a quadrilateral. A convex quadrilateral means that all of those vertices are pointing outwards. If you have a vertex that's pointing inwards, that means that it is a non-convex quadrilateral. So let's just take a quick look at some of these special quadrilaterals, and you can find all of this information on page 486 and 487 of your textbook that goes through all of it in lots of detail. But obviously we've got squares and rectangles. And now a square is basically a four-sided shape, all sides are equal, and all of the angles equal 90 degrees, okay? So it's like the equilateral triangle of quadrilaterals, okay, the square. Then you've got rectangles, and rectangles are basically a lot like squares, except for the fact that their side lengths are different, okay? So the side lengths, you have two that are the same, and then you have another two that are the same, but all internal angles are still 90 degrees. Now your rhombus is a lot like a square, okay? I often describe a rhombus as a square, and someone's come along and they've leaned on the edge of the square and the square's just shifted like that, okay? And what happens in that instance is that you have diagonal angles. So if I have a look here at angles, these two angles, they are equal, okay? And these two diagonals are also equal. So B and B are equal angles, and A are equal angles. Obviously, all of these, every single quadrilateral that we deal with, adds up to 360 degrees. Now, a rhombus and a parallelogram are the same type of things. A rectangle is the same. Once again, you've got a rectangle, and it turns into a parallelogram when someone leans on the side and it tilts that way a little bit. And diagonal angles are equal. Now, if we needed to find out the angles inside a rhombus or inside a parallelogram, you would only need to know one angle within those shapes. And then you could find the other three, okay, by doing that. Because obviously, if I know what angle B is, let's say angle B here is, let's make it easy, let's say 120 degrees. This one would also be 120 degrees. Okay, meaning that now I can find these two angles by taking 240 away from 360 and then dividing it by 2. The same would apply with a parallelogram. A kite, these two angles are the same. Okay, those two angles are the same. That's a really dodgy looking kite. I'm sorry I didn't draw that one better, but that's the thing to remember about a kite. And then you've got a trapezium, and the trapezium has two parallel lines. So none of the side lengths needs to be the same length, but obviously these lines that run here, they're parallel. And when you're finding out angle measurements with trapeziums, sometimes you can have an instance where you can use some of the rules that we've learnt, okay, when finding angles within parallel lines. So obviously alternate angles will be equal, and co-interiors will add to 180 degrees, and so on, okay? So they are your quadrilaterals. They're the special types of quadrilaterals. All of that information is there in your textbook, and I would encourage you to make sure for these 6, you know what those rules are.